Hello, cosmic explorers. Welcome back to our channel, where we dive into the mysteries of the universe. Today, we're tackling a mind-bending revelation that's shaking the foundations of astronomy. The James Webb Space Telescope, JWST, has potentially discovered objects that appear to be older than the universe itself. How is that possible? Let's explore this cosmic conundrum and unravel the implications of such a discovery. The cosmic puzzle just got more intriguing. You might be familiar with the discovery of 6 ancient galaxies that astonishingly contradicted our standard cosmological models. Originally, experts were hopeful these massive formations might be reclassified as different structures. However, the James Webb Telescope has thrown a curveball into the mix by detecting another galaxy that's even older and just as massive. This has led researchers to a humbling admission. Our current understanding of physics falls short in explaining the early universe's nature. But what do these revelations mean for the bigger picture? Could it be that the Big Bang theory is ready to be shelved? And if so, what new theories will explain the genesis of the cosmos? When the James Webb Telescope launched into the vast reaches of space on December 25, 2021, its mission was clear yet profound: to revolutionize our understanding of the universe. Now, less than 3 years after its celebrated departure from the McCann Space Center, it's evident that this billion-dollar marvel is not just meeting but exceeding its ambitious goals. Designed specifically for infrared observation, the James Webb Telescope is indeed changing the game with flying colors. The James Webb Telescope possesses the astonishing capability to detect the heat of a bumblebee on the moon from Earth. In practice, its highly sensitive infrared optics have already pinpointed the earliest active black hole, crowned the morning star of the cosmos, and charted the oldest known galaxies. Each new discovery by Webb not only expands our cosmic map, but also our potential for groundbreaking knowledge. However, this knowledge sometimes reveals that much of what we thought we understood about the early universe might be incorrect. This stark realization first dawned on experts early last year when the James Webb Telescope uncovered 6 ancient galaxies. These celestial bodies, formed just 500 to 700 million years after the Big Bang, shouldn't theoretically exist at all. Conventional cosmology would have expected these early star clusters to be relatively small and light. Yet, the universe doesn't seem too concerned with adhering to our earthly models. The mass of these newly discovered galaxies is almost comparable to that of our Milky Way today. Collectively, these structures contain more than 10 billion solar masses of stars, with one possibly boasting over 100 billion solar masses. This revelation not only challenges, but invites us to rethink our understanding of cosmic beginnings and the very rules that govern the universe. In light of the colossal mass of these newfound galaxies, lead astronomers from the University of Technology in Melbourne and Pennsylvania State University were initially convinced they had erred. However, despite rigorous verification efforts, the data stubbornly confirmed their initial findings. But why is this revelation so disruptive? The existence of these astonishingly massive galaxies upends almost all current cosmological models. Traditional theories suggest that the universe's first stars formed between 200 to 300 million years post-Big Bang. At the time these galaxies were detected, it was believed there simply wasn't enough normal matter to produce so many stars so rapidly. Yet, there's also a possibility that some of these celestial giants might be dust-covered black holes. But even this scenario wouldn't resolve the astronomical conundrum. It would simply reinforce the idea that the young cosmos contained far more stellar matter than previously thought. If even one of these galaxies is confirmed, it would profoundly challenge our understanding of cosmology. It could suggest that the density of matter in the early universe was much greater than our models have ever allowed. Such discoveries force us to rethink the very foundations of how the universe came to be and evolved. In an astronomical feat that seems to continually surpass itself, the James Webb Space Telescope, the most advanced of its kind, has once again shattered our cosmic perceptions. As recently as July 2022, astronomers celebrated the discovery of what was then the earliest known galaxy. GLAS 13 formed a mere 300 million years after the Big Bang. But Webb wasn't done yet. Leading the charge, researchers including Stefano Carini from the Escanor Superiore in Pisa have now identified a new record holder. This group of stars, known scientifically as JWST Zone 140, came into existence just 290 million years post-Big Bang, at a time when, by all accounts, the universe's first stars were just beginning to shine. This groundbreaking discovery was made public in early June, although the structure itself first came to light in Webb's images captured in the spring of 2023. Using the near-infrared camera, NIRCam, the team observed clear signs of an astronomical anomaly, a redshift greater than Z equal to 14. This revelation not only pushes the boundaries of our understanding, but also hints at cosmic growth patterns and structures that are entirely foreign to us. To grasp why this discovery is so groundbreaking, let's delve into the concept of cosmological redshift. In the spectra of galaxies, there are various absorption lines, and those from distant galaxies appear more redshifted. This redshift isn't due to the galaxies moving away from us, but rather the expansion of space itself. Astronomers often quantify redshift with the dimensionless value Z. For instance, a redshift of Z equals 1 indicates that the universe was half its current size when the light we now see was emitted. However, the redshift value alone doesn't tell us how the expansion occurred. This is what piqued the curiosity of experts when they observed a redshift of Z equals 4 degree of redshift and, by extension, provides clues about the early universe's structure and evolution. This profound discovery challenges existing models and invites us to rethink our understanding of cosmic history. The measurements are conclusive. This distant celestial realm was already a fully formed galaxy around 290 million years after the Big Bang. Yet, this is just the tip of the cosmic iceberg. Experts speculate that its formation likely began much earlier, requiring around 100 billion years to reach the expansive dimensions we observe today. However, it's not just the staggering distance or the galaxy's ancient origins that captivate scientists. What truly astonishes them is the galaxy's luminosity. Evaluations suggest it had already amassed several hundred million solar masses of stars by the time it was observed. This leads to an inevitable question: how could such a luminous, massive, and expansive galaxy form in less than 300 million years? Complicating this mystery are the unexpectedly bright emission lines of hydrogen and oxygen in the galaxy's spectrum. This finding is startling and suggests that several massive generations of stars had already completed their life cycles long before astronomers caught their first glimpse of this galaxy. Ultimately, this unexpected discovery challenges our previous assumptions and confirms that much about the universe remains beyond our current understanding. The traditional image of the early universe, populated by only small, dim galaxies, has been decisively overturned. Researchers now anticipate that this shift in understanding will only gain more support as the James Webb Telescope continues its mission. In the years ahead, this remarkable telescope is expected to uncover many more of these so-called impossible early galaxies. This brings us to a pivotal question: is the Big Bang theory still viable? Recent discoveries have prompted a growing number of scientists to reconsider the foundational aspects of this theory. As a brief refresher, the Big Bang theory posits that space, matter, and time all spring from an original singularity about 13.8 billion years ago. While this theory has achieved consensus status, supported by evidence like the cosmic microwave background radiation, even its staunchest supporters face unresolved questions. Key among these are the mysteries of how and why the universe came to be. How did everything emerge from nothing? Is it possible for something to originate from nothing? And was there a specific trigger? Or was it merely a random event? These questions, which delve into the very fabric of cosmic existence, have been highlighted by thinkers like Stephen Hawking and continue to provoke both awe and scientific inquiry as we probe deeper into the cosmos's mysteries. Stephen Hawking famously posited that time itself began with the Big Bang, suggesting that the event couldn't have been triggered by any preceding actions or entities. Yet, this leaves us grappling with the perplexity of cosmic uniformity. How is it that wherever we look, regardless of direction or distance, the cosmos presents similar densities and distributions of galaxies, nebulae, and radiation? Traditional explanations from conservative experts point to cosmic inflation, a rapid expansion that supposedly smoothed out these uniformities. However, a more radical theory, chaotic inflation, pushes this idea even further. It suggests that inflation ceased in only certain bubble-shaped regions, while elsewhere it perpetuated indefinitely. This scenario implies that countless sub-universes could have formed within these bubbles, each potentially governed by its own unique set of physical laws. Against this mind-bending backdrop, a fundamental question emerges. What if our cosmos is not the entire picture? What if there existed another universe before ours? In this paradigm, the Big Bang morphs into the Big Bounces, where the notions of beginnings and endings are not just questioned, but rendered obsolete. In such a model, what we've always called the Big Bang might be better understood as merely one transitional phase in an endless cosmic cycle. First things first, let's establish our current understanding. The universe is approximately 13.8 billion years old, a figure derived from measuring the cosmic microwave background radiation. This background acts like the afterglow of the Big Bang, providing a cosmic timestamp. However, the JWST has identified distant celestial objects whose light suggests they formed even earlier than this timeline allows. What does this mean for our understanding of cosmology? The JWST, a successor to the Hubble Space Telescope, is equipped with highly advanced technology designed to peer further into the past than ever before. Its powerful instruments can observe objects in infrared, allowing it to see through cosmic dust and gas. This capability is crucial for observing the most distant and oldest galaxies, hidden from view by the interstellar medium. The observations in question involve galaxies that are so distant their light has taken over 5 billion years to reach us. This puts their formation period close to the beginning of the universe. But here's the twist. Some data suggests these galaxies contain elements that should take several generations of star life cycles to form, hinting they might be older than the Big Bang's timeline. Several theories are circulating in the scientific community to explain these anomalies. One possibility is the existence of dark stars, or early stars made predominantly of dark matter. Another theory suggests there might be flaws in our current model of the universe's early expansion. These ideas are still in their infancy, but open exciting avenues for research. If validated, these findings could compel us to revise the timeline of the universe, or even our understanding of the physics underlying it. It challenges the robustness of the Big Bang theory and introduces more questions about what we know of the universe's earliest moments. The intriguing findings from the JWST underscore the importance of ongoing research and international collaboration in the field of astronomy. The JWST itself is a product of collaboration between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. As new data comes in, scientists around the world must work together to interpret these findings and develop new theories that can explain these anomalies. The more minds tackling this problem, the more likely we are to find a solution that fits with our broader understanding of the universe. Technological advancements like the JWST are pivotal in pushing the boundaries of our knowledge. Instruments like the JWST, with its ability to see in infrared and capture unprecedented details of distant objects, allow us to explore the universe in ways that were previously unimaginable. As technology continues to evolve, so too will our capacity to unlock the secrets of the cosmos. This could mean new telescopes, more advanced computational models, and even novel methods of observing and measuring astronomical phenomena. The potential discovery of objects older than the universe suggests that our current cosmological models might need revising. This isn't a sign of failure, but rather a natural part of scientific progress. Just as the heliocentric model replaced the geocentric one, our understanding of the universe is constantly evolving. Scientists might need to consider new theories about the formation and evolution of galaxies, the nature of dark matter and dark energy, or even entirely new physics to explain these observations. Discoveries like these capture the public's imagination and highlight the importance of funding and supporting astronomical research. Public interest in space exploration often drives the funding necessary for these ambitious projects. As more people become excited about these discoveries, the momentum for further exploration and innovation grows. This public interest also fosters a new generation of scientists and engineers inspired to pursue careers in astronomy and space sciences. Finally, these discoveries remind us of our place in the universe and the profound mysteries that still await us. Understanding the cosmos not only satisfies our curiosity, but also has the potential to bring about technological advancements that can benefit humanity in unforeseen ways. The study of the universe can lead to innovations in materials, science, computing, and many other fields. Moreover, it gives us a sense of perspective and unity, reminding us that we are all part of a larger, interconnected cosmos. One of the most profound implications of these findings is the need to revisit and possibly revise the Big Bang theory. This theory has been the cornerstone of cosmology for decades, explaining the origin of the universe. If objects older than the universe are confirmed, it could suggest that our understanding of the Big Bang might be incomplete, or that there was a pre-Big Bang state that we haven't yet conceptualized. The challenge of explaining these ancient objects will likely spur a flurry of activity among theoretical physicists. Concepts like multiverse theory, string theory, and quantum gravity might offer potential explanations. These fields are highly speculative, but represent the frontier of our understanding of the universe's fundamental nature. As data from the JWST pours in, physicists will be working overtime to develop models that can accommodate these new observations. Astrophysicists study the life cycles of stars and galaxies. Discovering objects that predate our universe could have significant implications for our understanding of stellar and galactic evolution. It may require rethinking the processes that lead to the formation of these celestial bodies and how they interact with the universe's fabric. The mysterious nature of dark matter and dark energy, which together make up about 95% of the universe, could be key to understanding these ancient objects. If these objects are somehow related to dark matter or dark energy, it might provide new insights into these elusive components of the universe. Current models of dark matter and dark energy might need adjustments based on these findings. The discovery of objects older than the universe challenges the cosmic timeline we've constructed. This timeline is based on the assumption that time started with the Big Bang. If this assumption is incorrect, our entire chronological framework for the universe's history might need a drastic overhaul. To make sense of these observations, scientists will rely heavily on advanced computational models. Simulations of the universe's formation and evolution, incorporating these new data points, will be crucial. High-performance computing and sophisticated algorithms will be essential tools in this endeavor. Cosmic inflation theory posits a rapid expansion of the universe, fractions of a second after the Big Bang. If ancient objects existed before this inflationary period, it could mean we need to reconsider how inflation occurred and what preceded it. This could lead to new models of the early universe that better fit the observed data. Gravitational waves, ripples in spacetime caused by massive cosmic events, could provide additional clues. If these ancient objects interacted with their environment in ways that generated detectable gravitational waves, it could offer another avenue of investigation. Observatories like LIGO and Virgo might play a key role in this research. Observing objects at such extreme distances and ages presents significant challenges. The JWST's advanced capabilities are just the beginning. Future telescopes and instruments, both ground-based and space-based, will be necessary to confirm these findings and explore their implications further. Cosmic dust can obscure our view of distant objects, but it also holds clues about the early universe. By studying the composition and distribution of cosmic dust, scientists can gain insights into the conditions that prevailed in the early universe. This might help explain the formation of these ancient objects. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.